Let's practice how to graph circles in a Cartesian plane. Similar to the items needed for us to come up with the standard form for the equation of a circle, in graphing circles, we also need to determine the center and the radius. But in this given here, for items 1 and 2 for this said practice exercise, we cannot immediately determine the value for the radius nor the center since we do have here the presence of expressions with the variables in its first degree. Take note that if we go back to our standard form, is they are expressed in terms of second degree x squared y squared. So to do this, we are going to manipulate this general form. They are actually in general forms because they are all equated to zero. We are going to come up with the standard form first, and after we have the standard form, we can determine later the center and the radius. So for number one, you have here x squared plus y squared, sorry for that, minus 2x plus 6y plus 1 equal to 0. This is in its general form. So we are going to transform it in its equivalent standard form. First step, move this constant to the other side or subtract both sides by 1. And you will have here x squared plus y squared minus 2x plus 6y is equal to negative 1. Why are we moving that constant outside? Because our next task is to come up with a perfect square trinomial. This constant may not be ready for the perfect square trinomial here. So we just need to come up with the values for constants that must be added to both variables x and y for us to come up with a perfect square trinomial. I'm talking about the step right after this when we are going to arrange our terms in such a way that the terms with the same variable are placed side by side. And then this is now the binomials, different pairs of expressions where we are going to add here a specific value for c and here as well so that it will become a perfect square trinomial. To do that, we do have a formula before to solve to get the process here is completing the square. To get the value for c, we just need to solve here. We have b over 2 square root of a. B and A here are the coefficients for the second degree and first degree respectively. So even if it's also y here, it also works that way. So for the value here, for the x coordinate variable, our b is negative 2, and you have 2. Our a is positive 1. Take the square for that. That's negative 1 squared. You have positive 1. In short, what we are going to do here is x squared minus 2x plus 1. So that this is now a perfect square trinomial. Okay? For the other variable, let's also use the same process to get the value for c. You have here your b is 6, and then you have 2 square root of a, which is 1, and take the square of it. 6 divided by 2 is a 3. That square root of 1 is still 1. 3 squared is 9. That means that what we are going to add here for the y variables to make it a perfect square trinomial is positive 9, which is equal to negative 1. This is not yet complete because please do not forget that the properties of equality tells us that whatever you add on one side, do the same thing on the other side. I'm talking about the value added here, 1 and 9. To neutralize what we added earlier, we also need to add here 1 and add here 9. We are trying to neutralize it so that the original equation is still similar to what we are doing here. The next thing here, since this is now a perfect square trinomial, we can now factor it into a square of a binomial. Square of a binomial. And what happens here is this. You take the root of the first term, x, take the root of the last term, 1. Square root of 1 is 1. And take the sign here of the middle term. Plus, the other side, you have y. A square root of y squared is y. Square root of 9 is 3. And then take the sign of the middle, and then that's your square of a binomial. This process is already part of your previous grade levels topic. Again, square root of x squared is x. Square root of the last term is 1. Take the sign of the middle term. Take the square root of this, take the square root of that, take the sign of the middle term. Is equal to -1 plus 1 is 0. We also have here 9. And then to finalize our standard form, you have here x minus 1 squared. Since our standard form uses subtraction for the binomial, we can express this as y minus -3 squared is equal to 9 can be expressed as 3 squared. Why do we do this? Please not forget that our standard form is in the form x minus h squared, or the square of x minus h rather. And you have here y, the square of y minus k is equal to r squared. We need our center at hk and our radius at r to draw our graph. So for this, our center is located at x minus h, x minus 1, that's 1, comma, y minus -3. From this, the reverse process for double negative property. So our k is not 3, but more importantly, it's -3. And our radius is equal to 3. So now that we have this value for our vertex and radius, we can just simply graph them in the Cartesian plane. First, let's locate -1 and 3. Sorry, 1 and -3 rather. So you have here 1, and you have 1, 2, 3, -3 at this point here. So this is our center. And then let's look at our radius. So from here, you have 3 steps from here. 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. Why I'm doing this is because the graph should pass through these points here, as they are also the distance, having a distance of 3. So I'm going to insert here rather a circular figure which is colored green. They must actually pass through these points for a while. Okay, so more or less it will look like this. This is the graph for number 1. Again, the process involved the understanding of the completing the square method so that we could have a perfect square trinomial, and then later on come up with a perfect square binomial to get our center and our radius as well for the left hand side of the right hand side of the equation. Let's use the same processes to get number 2. Number 2 here, let me use this, is actually x squared plus y squared minus 12x minus 4y minus 24, that's minus 24, equal to 0. First step is again, isolate the constant to the other side by adding both sides by 24. This is because so that we could have a freedom here on how do we manipulate, and by looking at the needed and necessary values to be added for us to have a perfect square trinomial. So this will become positive 24. And then let's rearrange this in such a way that we could pair up the expressions with the same variable, still 24 for this side. We're going to use the same process earlier to get the necessary constant. So for C here, you have -12 over 2 square root of A, which is 1, and square it. For the Y, you have here these values. B is -4 over 2 and square root of 1 here, square it for the value of c. So let's compute. Let us try to, let me first add here a space so we could have a better spacing later. So c for x variable, you have negative 12 divided by 2 is negative 6. Square it, you have 36. For the y variable, negative 4 divided by 2 is negative 2. Square it, you need 4. These are the values that you'll be adding this area here, and might as well add on the other side to retain the equality. So this will look like this. You'll have x squared minus 12x plus 36. And the other side, the second group, you have y squared minus 4y plus 4, which is equal to 24 still, but to be added with 36 and another 4 to retain the equality. Then we have two perfect square trinomial, and we could actually have a square of a binomial here. So let's have here square root of x, which is x. Let's use same color. And then square root of 36, sign of the middle term minus, and that's it. That's your square. Second group, square root of y squared is y. Square root of 4 is 2. Use this middle sign of the middle term, and that's your square. On the other side, 24 plus 36 is 60. Plus 4, you have 64. This is already okay. This is already in standard form. But for us to graph, we need a specific value for r. Okay, x minus 6, the square of it. We don't need this process earlier of the reverse double negative operation, since the values or the signs here or the operations here are already subtraction, which fit the description for our standard form. So you have y minus 2 and the square of it is equal to 64, can be written as 8 squared. From this, we can have our center, h minus h. So x minus 6, that's 6. Y minus k, y minus 2, so it's 2. That's our center. And our radius is 8. Let's try to graph this now in the same Cartesian plane. Let us use probably blue. And let's locate 6 and 2. 6 is somewhere here. 1, 2, 3, 4, 5, 6. Assuming that the grids again here are by 1. 6 and then 1, 2. So you have here the center. And to complete that, we will insert later on a circle here. But first, that said circle should pass through. We have 8 as radius. 1, 2, 3, 4, 5, 6, 7, 8 here. You have 1, 2, 3, 4, 5, 6. Sorry, that's 6, 7, 8 here. You have 1, 2, 3, 4, 5, 6, 7, 8. So it should be 8 steps, bottom, up, left, and right. So you have 1, 2, 3, 4, 5, 6, 7, 8 here. So it should pass all of this center. I mean, points on the circle. So if I'm going to add here a circle, I need to make sure it should pass here. A little bit adjustment here as well, and here, and that's it. So this is the circle, the graph of the circle for number 2, and this is for number 1. So again, before you could graph your circle, you need two things. Number one, the center, and number two, the radius. But for items like this, which are placed are given in general form, you need to apply the manipulative processes such as getting a perfect square trinomial and then getting a square of a binomial to get the correct vertex. And please not forget, not vertex center. And please don't forget this process here wherein if it's plus, it can be reversely written as double negative. And then of course, the radius here maybe is advisable to have a square of a number so that you could know its radius. Because if you will not, some of you might say the radius is 9, it might be too large. So thank you very much for watching. Hopefully you have learned something, and then please continue working on this on your own. Goodbye, everyone.